Welcome to part 2 of Competency 13. In this video, we will work with mutually inclusive and exclusive events. Mutually inclusive events are events that can occur at the same time. And in the case that you wish to have one event or the other event, but not both, we have the formula above to deal with these situations. As we move along, we will discuss if each situation is mutually inclusive or exclusive. And do we need to use the precise formula given that we see here? Okay, let's look at number 1. If an ordinary number cube is rolled twice, what is the probability of getting a sum of 3 or sum of 8? Okay, I have taken the liberty of writing these out for us. So we have 2 desired outcomes for 3, and we have 5 desired outcomes for 8. And notice that it says 3 or 8. Well, we know that that's going to be a plus, but we do know that this is mutually exclusive. Why do we know that? Because they cannot happen at the same time. So if we were to subtract out anything, as this formula above says, we're subtracting out 0 because it can't happen together. Either it's going to add to be 3 or it's going to add to be 8 as desired, or it's going to add up to be something else, but we don't care about the something else. So we have a nice formula where we can do this. The only thing is, be careful. You know that you have first, we have 2 desired situations or roles, okay, where we get 3. And then we have 5 where we get 8. But remember, you rolled it twice. Each time, that's how I've written it out. It looks like coordinate pairs, but they're not. I typed it so you see that they are pairs. So you have pairs. Well, that means 2 rolls. So the total outcome for each of those situations is the first time the total outcome is 1 to 6. Okay, so that's 6. And then again, for the next roll, that's 6. And then again, when you are trying to get 3 or 8 because of 2 rolls. Now, this can be confusing to think out. Just go back, think about what actually happens again. You're not talking about the individual roles themselves. You're talking about an overall situation. So let's put this in the calculator and see what we do actually get. Okay, when we do everything we need. All right. Well, what it's going to do, it's going to reduce it down for us, is what I mean by that. Okay. So let's put that in. Let's see. 2 over 6 times 6. And no, I'm not going to try to do any of this in my head. So plus, and my fraction, I have 5 and 6 times 6. Now, I don't need to say minus 0. Okay. Because it's not going to happen at the same time. I'm not even going to worry about that. So enter, and it has reduced down very nicely, giving us option B. Okay, let's go on to number 2. Number 2, if a single card is drawn from a standard deck of cards, what is the probability of selecting a king or a heart? Now, in this situation, we will use the formula, okay? And one big key is we have or, okay? And another thing is we need to subtract out where a king is also a heart. There is one instance where we have a king that is a heart out of the 52, and we have 52. Let's see, kings, we have 4 kings. And then out of the 52 hearts, we have 13. Okay, so when we put that in the calculator, we have 4 over the 52 plus another fraction, 13 out of the 52. Now you have to subtract out the one king that is also a heart. Can't have repeats. Okay, so we have one of those and 52. Okay, now of course you could have seen that a little simpler, but I'm typing it in the way I explained it. Okay, all right, now let's push enter, and that gives us a 4/13. Okay, now let's look at number 3. If an ordinary number cube is rolled twice, what is the probability of rolling an even number and then an odd number? Okay, first thing you need to note, those cannot happen together. Okay, so that is going to be how many even do we have? 2, 4, 6, that's 3. How many odd do we have? 1, 1, 3, 5. That's 3 out of 6. So we don't have to worry about subtracting out things that happen at the same time. So this is all we have. We have our fraction in 3 out of 6. Don't worry about reducing. Okay. And it says the word and. That means multiply them. Okay, it's not like above where it says or. Okay, and now we have another fraction that is 3 out of the 6 total outcomes, which gives us 1/4, and that is also A. All right, now let's look at number 6. Oh, I'm sorry, number 4. I said 6 and then I said, oh, let's say number 6. Okay, let's see. Okay. A bag of jelly beans has 8 yellow, 6 red, 4 black, and 7 green jelly beans. If you eat 2 jelly beans one at a time, what is the probability of eating a red jelly bean followed by a green one? Okay, well, it says, okay, you have followed by red, followed by a green. That situation means you're going to eat both of them. Okay, you're going to eat 2 of them, which implies and. So that means we are multiplying. Okay, so let's clear out our calculator and I'm going to start my fraction. First fraction is the red jelly bean. Okay, in red there are 6 of them. But we need to look at how many total jelly bean we have. I see 10 plus 15, that gives me 25 jelly beans. And I know I will eat both of them, so that's multiplying. It implies and. Okay, and then it says a green one. All right, so let me set up my fraction. Well, how many green do we have? We have 7. But do we still have 25 jelly beans? No, we do not. We have 24. Okay, now push enter. And we have a reduced fraction, which gives us option C. All right, let's go to number 5. Number 5, 3 cards are randomly drawn from a deck of playing cards in succession without replacement. What is the probability that the first is a king, the second is an ace, and the third is a queen? Okay, the word and tells me we're going to multiply and we are not replacing. So each time my denominator will be reduced by 1. 1 card less in my deck. So my total outcomes is decreasing 1 at a time. So let's put that in the calculator. So to begin, I have 4 kings out of a total of 52. Then I have multiplication. Now I have aces. I have 4 aces in a deck, but I'm down 1 less card. So I have 52. I go over and I multiply, and here's my third draw. Still saying there's 4 queens, but what's the probability of now getting uh, that my total outcome? It's going to be 50. Sorry about that. Okay, now I push enter, and wow, very serious decimal. Okay, well, don't think you're wrong automatically, and we can try the toggle button, and that's not going to work. That doesn't tell me I'm incorrect. What this tells me is that it's a very small decimal, and my calculator just isn't powerful enough to give me what I need right now. So that excludes A, and D. My calculator can handle those. So let's try B, okay? So set your fraction up, and we have 8 over 16575. Yes, and push enter. And that is the exact same decimal. So I'm going to say option B. Now, if you want to go back up and capture what we had and type over, see, I'm going to type over the 8 with this 7 from C. Okay, and let's see what we get. Close, but not the same. So it is option B. Okay, number 6. A card is drawn from an ordinary deck of cards. What is the probability of drawing a number card not including the ace or a king? Okay, the first thing I notice is that we're talking about drawing once. So the possibility of having stuff happen simultaneously or something happening at the same time is not applicable here. So that equation that we had prior just doesn't apply here. But we do have the or, which tells me we have the addition. Okay, so let me clear everything out. Okay, to begin, it says drawing a number card. Well, how many number cards are there in a deck? We can't use the ace. So that's from 2 to 10. Well, there are 9 of those in each suit. So there are 9 hearts, there are 9 diamonds, and 9 clubs, and 9 spades. So that's times 4. Okay. Then I go down and say, wait a minute, what's my total outcomes? Well, the total outcomes is 52 still. Then I go over and I'm adding because of the word or. You set up your fraction. Well, that's a king. Okay, we're not talking about all the other cards in the deck, just king. So there's 4 out of 52. And I'm not worried about something happening simultaneously, nor am I worried about replacement because we're talking about drawing one single card. Okay, so let's push enter and it automatically gives us a reduced or simplified answer, which is D. Number 7, a bag of 50 marbles has 20 red, 15 blue, 10 green, and the rest are yellow marbles. If you select 2 marbles with replacement, what is the probability that you will select at least 1 red marble? Okay, what do we need to do? Well, first thing we need to realize is that at least 1 marble, but not both. Okay, and at least implies or. It's one or the other. Draw, because we're talking that you will select 2. So it's one or the other will be the desired selection, but not both. So what does this mean? In our calculator, we have, okay, how many red? At least 1 red. So red is 20. Okay. And that is out of the 50 in the bag. And because we are saying at least, that's one or the other, that's addition. Okay. Now we have another fraction. Okay. And again, that's 20. And we replaced, so we still have a total of 50. But now what's going to happen? Well, it says not both, or the implication is at least one, but not both. You have to remember that. Okay. So now we have to apply the equation that we had talked about prior, or the formula that we had talked about. So we subtract, and I always like to use parentheses, set up my fraction again, and that would be for both that, because we have 2 selections, that is going to be 20 times 20. So I'm going to square it because we're multiplying. Remember, you have to take the 20 out of 50 times the 20 out of 50. That would be if it happens twice and we are replacing. Okay, now I'm going to go down and that would still be 50. Oh, but since we said 20 squared there, we can say 50 squared. Okay. All right, now let's push enter. And that gives us option C. Okay, if you didn't understand what I was doing, okay, on the second one, I kind of cut to the chase and skipped a step. So the first one, we had 20 out of 50. Well, it says at least, so that's one or the other one. So that means add. Then we have 20 out of 50 because we replaced, and we still have 20 red marbles. But on the subtraction, you have to say 20 out of 50 times 20 out of 50. Okay, so what I did is I just squared them both because it's the same thing. And when you're trying to take the test, if you can see that, you will actually save yourself quite a bit of time. Okay, this is the last question in this video. And I wanted to thank you for watching, sharing, and liking and subscribing. You guys are the best. Thank you very much and happy testing.